Okay, this is the back page of the review. That was optional, so it was the two-sided review. It looks like this, front and back. So I have the front side was part 1. The back side here is going to be part 2. So again, guys, just skip ahead to the parts you need. You don't need to watch the whole thing unless you need the whole thing. Number 1, it's saying it's a parallelogram. So for each parallelogram, choose the best name and then find the measure of each angle. So I think it's better to find the measures of each angle first, because this one is going to be at least a rhombus. But if these are all 90-degree angles, then we're going to have a square. So we got to know the angles first, and then we can determine what the best name for our parallelograms are. We know in a parallelogram we have 2 pairs of parallel sides, so we know alternate interior angles are congruent, so that's 54. We also know this is an isosceles triangle. So this is going to be 54 because the isosceles triangle theorem says that the base angles of an isosceles triangle are congruent, which means this one is also 54. Because this is also an isosceles triangle, and we also know alternate interior angles are congruent. Right. 3 angles of a triangle add up to 180, so the measure of angle 4 plus 54 plus 54 is going to be 180. That's the triangle sum theorem, which says the 3 interior angles of a triangle add up to 180. 54 and 54 is 108. We subtract 108 from both sides. The measure of angle 4 is going to be 72, which means this one is also 72. Opposite angles are congruent. Or we could add these up again. It's going to be the same thing. So this is definitely just a rhombus. It's not also a square. 54 and 54 is 108. So 108 plus 72 plus 108 plus 72 equals 360. We know the 4 angles of a quadrilateral add up to 360 degrees. Number 2, it's telling us we have a right angle. And it's some sort of parallelogram, so we know the 2 pairs of opposite sides are parallel. So we can do alternate interior angles. So we know this angle 3 is also going to be 18, which allows us to find this angle. Because this is a right angle, so these 2 have to add up to 90. So 90 minus 18 is going to give us 72. Okay, let's back up a minute here. We know consecutive angles are, so it's a parallelogram. We know opposite angles are congruent. So opposite angles are congruent. So if this one's 90, this piece is also going to be 90. And consecutive angles are supplementary. So we know these 2 angles add up to 180. So 180 minus 90 is going to give us 90. So we know we have a 90-degree angle there as well, because consecutive sides are supplementary in parallelograms. Again, this also means that one is going to be 90 as well, because consecutive angles are supplementary and opposite angles are. So we have 90, 90, and 90. We know this is a rectangle. 4 right angles define a rectangle. A rectangle is a parallelogram with 4 right angles. Okay. From there, we can then find our other angles. Okay. So we know in a rectangle, all of these are congruent. All these sides are congruent because the diagonals are congruent, and the diagonals bisect each other because it's a parallelogram. Right. So one of the properties of a parallelogram is that diagonals bisect each other, meaning this piece and this piece are congruent, and this piece and this piece are congruent. But in a rectangle, one of the properties it lists on a reference sheet is that the diagonals are congruent. So since both those properties are true, all 4 of these pieces on the inside are going to be the same. Okay. Alternate interior, as we said, that gives us 18. We know this whole thing is 90, so 90 minus 18 gives us 72. We have an isosceles triangle, so 72. So the measure of angle 2, write it down here, the measure of angle 2 plus 72 plus 72 is going to equal 180. These three. It's the triangle sum theorem. The three interior angles of the triangle add up to 180. Measure of angle 2 plus 72 and 72 is 144. We subtract 144 from both sides. The measure of angle 2 is going to equal 36. So we know this one is going to be 36. You guys, when I read over it, I don't think you guys can see it very well, but it looks like it's okay. 36 right here. So again, this is 36, and then these are 72 and 72. So then if this is 36, we have a linear pair between 2 and 4. 2 and 4 are a linear pair. So 180 minus 36 is going to give us 144. So the measure of angle 4 is going to equal 144. The measure of angle 2 was 36. Which we got. Okay. Let's do 4 and 5. Well, we have plenty of room. 3 and 6. So again, if this is 90, we know consecutive angles are supplementary. So 180 minus 90 gives us 90. So this one's also going to be 90. So we know, again, this is going to be a rectangle. Caught myself with again there, so we'll put 10 more on the list. Since this is 106 degrees, we have vertical angles, so angle 3 is going to be 106 degrees. And then we have a linear pair. 3 and 4 are a linear pair. So 180 minus 106 is going to give us 74. Trying to think of an easier way here. So it's a rectangle, so all 4 of these are congruent. So let me erase. So I'm going to erase for 3 and 4 in the middle. Since it's a rectangle, we know these are going to be 90 and 90 because the opposite angles are congruent. We know all these pieces are going to be congruent, so we have an isosceles triangle. If we call this x and x, we now can look at the 3 angles. The triangle, x plus x plus 106 equals 180. Subtract 106. 2x, combined like terms, is going to equal 74. Divide by 2. X is going to be equal to 37. So we have 37 and 37. And then this is 90 degrees. So 90 minus 37 is going to give us 53. So the measure of angle 2 is going to be 53. All right. Let's do 4, 5, and 6. This is going to take forever. I'm going to try to pick the pace up a little bit here. So let's say rhombus. Say rhombus. So we know diagonals are bisected. The diagonals bisect the opposite angles. So if this is 59, 4 is also going to be 59. Okay, which means these two are also going to be 59 and 59 because they're alternate interior. We can find these two by finding what this whole thing is. So we know that this piece right here, this whole thing here is going to be 59 plus 59, which is going to be 118. So these are supplementary angles. So if this is 118, we can do 180 minus 118, which gives us 62. So this whole thing over here is 62. Since that's 62 and we know that the diagonals bisect opposite angles, we know that, and it's because it's a rhombus, we know it's a rhombus because all four sides are congruent. So this is best described as a rhombus. We know 62 divided by 2 is going to give us 31. So these two angles are going to be 31 and 31. Since we know that's 59 and that's 31, we know the three angles of a triangle add up to 180. So the measure of angle 3 plus 31 plus 59 is going to be 180. The measure of angle 3, that's going to be 90. So the measure of angle 3 is going to be 90. So a little bit extra work. We didn't really need to do that. We know also in a rhombus that the diagonals are perpendicular. And since the diagonals are perpendicular, we know we're going to have right angles. So we're going to have 90, 90, 90, and 90. So 2 and 3 are going to be 90 because diagonals of a rhombus are perpendicular. So that means perpendicular means that the two lines are going to form right angles. And then we have the diagonals of a rhombus bisect the opposite angles. So that means that this is 59, angle 4 is also 59. So we have 59 and 59, and then we can get angle 1 by doing alternate interior angles. So 59 and 59 as well. Well, extra work. Didn't need to do all that, but that's fine. Problem solving. Number 5. So we know it's a parallelogram, so we know opposite angles are parallel, which means we know we have alternate interior angles that are congruent. So if this is 30, angle 2 is going to be 30, and angle 1 is going to be 60. Which means we have right angles because 30 and 60 is 90. 60 and 30 is 90. We know consecutive angles are supplementary. So since this is 90, this whole thing is also 90, and this one's also 90. Because consecutive angles in a parallelogram have to add up to 180. So we know since it has 4 right angles, it is a rectangle. Okay, and then we know a rectangle, all the pieces in the middle are going to be congruent because the diagonals bisect each other and the diagonals are congruent. So since they're congruent and they bisect each other, each of these 4 pieces is going to be congruent. Which means we have an isosceles triangle. So this is going to be 60 and this is going to be 30 because the isosceles triangle theorem says the bases of isosceles triangles are congruent. These would be the bases of the isosceles triangles. Number 6, 4 sides are congruent, so we have a rhombus. So let's not make the same mistake we made last time. Angle 4 is going to be 90 degrees because we have a rhombus. It wasn't a mistake, we just went the long way. But in a rhombus, we know the diagonals are perpendicular. So all the angles in the middle are going to be 90 because the definition of perpendicular lines are lines that intersect and form right angles. Again, the other property of a rhombus that we know, or one other property, is that the diagonals bisect the opposite angles. So if this is 68, this is going to be 68, which means 2 and 3 are also going to be 68 and 68. Okay, we know this is 90, 90, and 90. So to find 1, we already have the other two pieces of the triangle, 68, 90, and 1. You guys can't really see what I'm writing, but as long as you can hear me. We're going to have the measure of angle 1 plus 90 plus 68 equals 180. This is going to give us 158. So the measure of angle 1 plus 158 equals 180. Subtract 158. And that's going to be the measure of angle 1 is going to equal 22. So 68, 68, 68, and 68. 90, 90, 90, and 90. And then these three angles add up to 180. So we get 22, 22, 22, 22. Okay. You guys can kind of read that. Maybe not on your phone, but. So that's 1 through 6. Okay, so now we have rectangles. 10 through 13 here are rectangles. So I'm going to leave a lot of space up top so I can draw these out. 10 through 13 here are rectangles. So when we draw, again, we have to make sure we are ordering our vertices in clockwise fashion or counterclockwise fashion. We can't jump across diagonals. So let's draw A, B, C, D, or A, B, C, D, or A, B, C, D, or A, B, C, D. As long as we are going in order, clockwise or counterclockwise, not jumping diagonally. We can't say A, B, C, D. Okay, we can't jump diagonally. You have to go clockwise or counterclockwise. So HJ, whoops, this isn't even the name. Our quadrilateral, our rectangle is HI, JK. And make sure you go clockwise or counterclockwise. HJ, so this is X. IK is 2X minus 7. Write them over it. So we know the diagonals are congruent in a rectangle. So we're going to have X equals 2X minus 7. Right, so it's the whole thing. It's hard to draw it to represent it, but this one's X, this is 2X minus 7. We're talking about the whole thing here. Subtract X from both sides. We get 0 equals X minus 7. Add 7, we get 7 equals X. We substitute back in to make sure it works. 2 times 7 is 14. 14 minus 7 is 7. And then we have X 7, so it works out. Same thing for 11, 12, and 13. So for 11, HJ is going to be 3X plus 5. IK is going to be 5X plus 5X minus 9. Those are the diagonals, so they're going to be congruent. So 3X plus 5 equals 5X minus 9. Subtract 3X, 5 equals 2X minus 9. Add 9 to both sides. 5 and 9 gives us 14. 2X divided by 2, X equals 7. We can substitute it back in to see if it works. 3 times 7 is 21. 21 plus 5 is 26. 5 times 7 is 35. 35 minus 9 is 26. 12, so we have 3X plus 7 is HJ, and JK, IK is 6X minus 11, so subtract 3X. We get 7 equals 3X minus 11, add 11. That's 18 equals 3X, divide by 3, we get 6 equals X. Substitute back in. 3 times 6 is 18. 18 plus 7 is 25. 6 times 6 is 36. 36 minus 11 is 25. Okay. Last one. Do it right here, kind of. 19 plus 2x is going to equal 3x plus 22. Subtract 2x. 19 is going to be x plus 22. Subtract 22. Negative 3 is going to equal x. Get a negative value is fine as long as the sides are not negative. So you can get a negative x value as long as the sides are not negative. So let's substitute in, make sure we have positive side lengths. So 19 plus, so 2 times negative 3 is negative 6. 19 minus 6 is 13. Here we have 3x plus 22. So 3 times negative 3 is negative 9. Negative 9 plus 22. Negative 9 plus 22 is going to be 13. So we're good. So here we have 14, 15, and 16. Okay, these are rhombuses. Okay, so we're not going to find the area. We're just going to find the measures of the numbered angles. So 14, we know the diagonals in a rhombus are perpendicular. So we know 1 and 2 are going to be 90 because all 4 of those angles in the middle are 90. So the measure of angle 1 is going to be 90. The measure of angle 2 is going to be 90. Because diagonals are perpendicular. Perpendicular lines are lines that intersect and form right angles. We also know in a rhombus that the diagonals bisect the opposite angles. So if this is 29, this one is going to be 29. Opposite or alternate interior angles are congruent because in a rhombus is a parallelogram, so it has 2 pairs of opposite sides that are parallel. So since the lines are parallel, the alternate interior angles are going to be congruent. So 29 and 29. So the measure of angle 3 is 29. The measure of angle 4 is going to be 29. Fairly straightforward. They're giving us information about the lengths of sides, but that's not relevant to finding the measures of angles. That's relevant to finding the area. We're not worrying about part B, finding the area. So we're not going to worry about that for this part, for this test. Don't worry about the area. Okay, it's a rhombus, so they're all right angles in the middle. So the measure of angle 2 is going to be 90. We know opposite angles are bisected by the diagonals in a rhombus. The diagonals bisect the opposite angles. So if this is 20, this one's 20. We know these are 20 and 20 because a rhombus is a parallelogram, so it has 2 pairs of parallel sides. So if the lines are parallel, the alternate interior angles are congruent by the alternate interior angle theorem. We know consecutive angles are supplementary. So this angle of the quadrilateral is going to be 40 because 20 plus 20 is 40. Consecutive angles are supplementary, so 180 minus 40 is going to give us 140. So this whole angle here, if I erase the middle here, is going to be 140. Okay. Since we know diagonals of a rhombus bisect the opposite angles, we know it's going to get split in half. So 140 divided by 2 is going to be 70. So we know these angles are going to be 70, 70, 70, and 70. So the measure of angle 1, the measure of angle 3, and the measure of angle 4 are all going to be 70, 70, and 70. Number 16, right away, rhombus. In a rhombus, the diagonals are perpendicular. We also know in a kite that the diagonals are perpendicular. So in a rhombus and in a kite, we know diagonals are perpendicular, so they form 4 right angles. So we know the measure of angle 2 is 90. The measure of angle 3 is 90. It's telling us this angle, well, is it telling us sides? Those are telling us sides, the 10 and the 13. So we're just going to not worry about area, stick with the angles. So in a rhombus, diagonals bisect the opposite angles. So if this is 52, this angle is also 52. Okay, and then these would be 52 and 52. We know consecutive angles are supplementary. So if both of these are 52 together, they're 104. So if I draw it again, okay, we're going to have 104. So what's this angle? Well, it's going to be 180 minus 104, which is 76. So the whole thing's 76, but we have a diagonal. So we divide by 2, and we get 38. Because diagonals bisect the opposite angles in a rhombus. So we're going to end up getting 38 and 38. Alternate interior, we're going to get 38 and 38. So the measure of angle 4 and the measure of angle 1 are going to be 38 and 38. Okay. So the last page, or the last part, we have isosceles trapezoids. Isosceles trapezoids. So number 1 here. With isosceles trapezoids, we know the base angles are congruent, and we know the consecutive angles between the bases are supplementary. So the base angles are the, bases are the 2 sides that are parallel. So here's our arrows indicating the parallel sides. So here's a base, here's a base. So the consecutive angles between the bases are supplementary. The base angles themselves are congruent in isosceles trapezoids. I'm going to erase the bases here. So we know the measure of angle 2 is going to be 62 because those are base angles and base angles are congruent. And then we know these 2 angles are supplementary because they're consecutive angles between the bases, and in an isosceles trapezoid, consecutive angles between the bases are supplementary. So 180 minus 62 is going to give us 118. So we know the measure of angle 1 is 118. And this one would also be 118. Again, we notice, there's again, so I probably missed it 100 times. 118, 118 plus 62 plus 62 is going to give us 360. The 4 angles of a quadrilateral add up to 400, or add up to 360. So here we have 2 bases. Base angles are congruent, so the measure of angle 1 is going to be 99. 99. Consecutive angles between bases are supplementary. So 1 and 2 are consecutive angles that are between the bases. The bases are the 2 sides that are parallel as indicated by the arrows. So 180 minus 99 is going to give us 81. So we know the measure of angle 2 is going to be 81. This one is also going to be 81 though, because these are base angles and these are base angles. So 99, 99, 81, and 81 add up to give us 360. So the measure of angle 2 is going to be 121 because base angles are congruent. And then 180 minus 121 is going to give us 59. So the measure of angle 1 is going to equal 59 because consecutive angles between the bases are supplementary. Then this one would also be 59. Number 4, same deal. These are base angles, so the measure of angle 1 is going to be 96. 180 minus 96 is going to give us 84. So these are consecutive angles between the bases. The bases are the two sides that are parallel, as indicated by the arrow. So the measure of angle 2 is going to be 84. So 84, 84, 96, and 96. Number 5, base angles are congruent. So the measure of angle 2 is 79. (180) minus 79 is going to be 101. So the measure of angle 1 is 101, because we know that consecutive angles between the bases are supplementary. Number 6, the measure of angle 1 is going to be 67. Then 180 minus 67 is 113. Blanking for a minute there, but it's going to be 113. So we know the measure of angle 2 is 113 because the consecutive angles between the bases are supplementary. So 67, 67, 113, and 113. The key or the thing we want to recognize here, though, at the very least, is these are isosceles trapezoids. So if we have if we do not have an isosceles trapezoid, the bases are not congruent. The consecutive angles between the two bases are still going to be supplementary. That's fine, but the bases are not going to be congruent. Neither base angles. The base angles are not going to be congruent. We just want to highlight that. You have to make sure you have an isosceles triangle, which means you have to make sure the legs are congruent. If the legs are congruent, you have an isosceles triangle, and then you can say the base angles are congruent. Just like in an isosceles trapezoid, right? Just like in an isosceles triangle. So an isosceles triangle, in order to say the base angles are congruent, you have to say the two sides are congruent. Likewise, in the isosceles trapezoid, if the base angles, if the legs are congruent in the isosceles trapezoid, then the base angles are congruent. If we don't have congruent legs, we don't have an isosceles trapezoid, we don't have congruent base angles. All right. Find the variables. So these are isosceles trapezoids. We know the legs are congruent. So 3x minus 3 is going to equal x plus 5. Subtract x. 2x minus 3 equals 5. Add 3 to both sides. 2x is going to equal 8. Divide by 2. X is going to be 4. We can double check by substituting it in. 4 plus 5 is 9. 3 times 4 is 12. 12 minus 3 is 9. So the legs are congruent. They have the same length. Number 8, we've already been through this, 1 through 6. So we know consecutive angles between the bases are supplementary. So 6x plus 20 plus 4x is going to equal 180. 10x plus 20 equals 180. Subtract 20. 10x is going to equal 160. Divide by 10, x is going to equal 16. We can substitute that back in to make sure. 4 times 16 is going to be 64. 6 times 16 is 96. 96 plus 20 is 116. 116 plus 64 is 180, so we're good. And then base angles are congruent in an isosceles trapezoid. Since the legs are congruent, it's an isosceles trapezoid. So our base angles are congruent, so y is going to be 116. Right, because this angle is 116, y is also going to be 116 because base angles are congruent. If we wanted that equation, right, y equals 6x plus 20. So y equals 6 times 16 plus 20. So y equals 96 plus 20. So y equals 126. Number 9. What do we have going on in 9? Okay, we have. I'm gonna erase the y stuff here. Legs are congruent, so we know 7x equals 2y plus 5. Is that all we have? Huh. Interesting. That would give us infinite amount of solutions. Because for every x value, there's going to be a different y value. There's got to be something missing, right? I don't know. Yeah, I mean, I don't know. Unless there's an additional part of the problem saying that, because we know the diagonals are congruent. We know diagonals are congruent in a isosceles trapezoid, but I'm not really sure. We would need to know what the diagonals are or something. There's no way we can do this like this. There's going to be an infinite amount of solutions. I guess just divide by 7. X is going to equal 2y plus 5 over 7. So I guess our point is 2y plus 5 over 7, comma y. And we have, I don't know. Let's just skip it. I'm sorry, guys. My knowledge is limited. I think they're just missing something from the problem. But, yeah, I don't know. Okay, what do we have? 9 left? Jeez, Louise. 9 left. On the kites. Okay. Number 10. We know angle 1 and angle 2 are congruent. We have kite. We have one pair of opposite angles that are congruent, and that's the angles that are between the two pairs of congruent sides. Remember, so kites are defined as not having any parallel sides and having two pairs of adjacent sides that are congruent, or two pairs of consecutive sides that are congruent. So between the two pairs, we're going to have angles that are congruent. So if we call it x, we know that x plus 101 plus 48 is going to equal 360, because we know the four angles of a quadrilateral add up to 180. So we're going to get 2x, combined like terms. 101 plus 48 is going to give us 149. That's going to equal 360. Subtract 149. We know 2x is going to equal 211, it looks like. Divide by 2. X is going to equal, that's going to be 105.5. So each of these angles is going to be, so the measure of angle 1 is going to be 105.5, and the measure of angle 2 is going to be 105.5. Well, that's a 48. No, yeah, no, that's right. That gives us 210 plus, gives us 211 plus 149, 360. We're good. Let's zoom in. I'm going to zoom in on these. So we did the first one. Let's do, we can fit all 4 of these. So let's do what? We'll come back to 13. So here's 11, 12, 14, and 15. So we know the diagonals of a kite are perpendicular. So just like with a rhombus, we have 4 right angles, 90, 90, 90, and 90. So the measure of angle 1 is going to be 90. We know we have 90 degrees here because it's a right angle, because the lines are perpendicular. Perpendicular lines are lines that intersect and form right angles. So we have the measure of angle 2 plus 90 plus 65 is 180, because the 3 angles of a triangle add up to 180. Combine like terms, measure of angle 2 plus, this is 155. Subtract 155. The measure of angle 2 is going to be 25. This is just like number 10 then. So between the 2 adjacent sides that are congruent, we have congruent angles. So there's only one pair of congruent angles in a kite, and that's the 2 angles that are between the 2 pairs of congruent sides. So we can label it x and x. So we know x plus 44 plus 80 are going to equal 360, because the 4 angles in a quadrilateral add up to 360. So we have 2x plus 124 equals 360. Subtract 124. 2x is going to equal, that's 236. Yeah, 236 divided by 2. We're going to get x is 118. So take half of 200 and half of 36. Half of 200 is 100. Half of 36 is 18. So we know it's going to be 118. So we have 118 and 118. The measure of angle 1 is 18. The measure of angle 2 is 118. All right, let's do 14 and 15 while they're up. 14 is the same as 12. So we're going to label these x and x. The 4 angles of the triangle add up to 360. We have 1 pair of congruent angles in a kite, and those are the angles that are between the 2 pairs of congruent sides. So here's 1 pair of congruent sides. Here's a 2nd pair of congruent sides. So the angles between the 2 pairs of congruent sides are our congruent angles. If we label each of them x, we know that x plus 59 plus 87 is 360, because the 4 angles of a quadrilateral add up to 360. So we have 2x plus, so 2x, that's going to give us, 80 plus 60, it's 140. So 146. Right, that's 9 plus 87 is 96. 96 plus 50 is 146. Subtract 146. 2x is going to be, so it's 214 divided by 2. X is going to be 100. So the measure of angle 1 is 107. The measure of angle 2 is 107. 15. Diagonals in a kite are perpendicular. Perpendicular lines intersect to form right angles. So we're going to have 4 right angles. So the measure of angle 1 is going to be 90. And these are also going to be 90 and 90. They're telling us this angle is 51. So we can do 51 plus 90 plus the measure of angle 3 is going to be 180, because it's the 3 angles of a triangle. We know the three angles of a triangle add up to 180. So 51 and 90 gives us 141. We subtract 141 from both sides. We get the measure of angle 3 to equal 39. 39 is there. And then we know the measure of angle 2. So since these angles are congruent, and we have an isosceles triangle here. So this is an isosceles triangle. We know these two angles are going to be the same. So if this one's 51, this one down here is also going to be 51. So the measure of angle 2 is going to be 51. Okay. Let's go back and do 13, and then we'll do 16, 17, and 18. So 13. So we have 90 right angles because we know in a kite diagonals are perpendicular. They're also perpendicular in rhombuses. So we have 90, 90, 90, and 90. So the measure of angle 1 is 90. Here we have the three angles of a triangle. So the measure of angle 2 plus 90 plus 27 is going to equal 180 because the triangle sum theorem says the three angles of a triangle add up to 180. So the measure of angle 2 plus 90 and 27 is going to give us 117 equals 180. Subtract 117. Measure of angle 2 is going to give us 63. And just like on 15, here we have an isosceles trapezoid. An isosceles triangle. So if this is 63, this is also going to be 63. So the measure of angle 3 is then also going to be 60. Okay, that's 13. 3 more. 16, 17, and then we'll do 18. Okay, so the same thing here, except we're just using algebra instead of numbers. Algebra instead of numerical values. So the middle angles are 90, 90, and 90. So this one's 90. Which means that these three angles are adding up to, they just want us to find x. So these three angles are going to add up to 180 because those are the three angles of a triangle. So we have 2x plus 10x minus 6 plus 90. It's going to equal 180. We can combine like terms. That's 12x plus 84 equals 180. Subtract 84. 12x is going to equal 96. Divide by 12. And we get x equals 8. X is right because 48 divided by 12 is 4. 48 times 2 is 96. So 96 divided by 12 is 8. 17. Okay. We have right angles, so all of these are 90. So 90, 90, and 90. The angles between the two pairs of adjacent sides that are congruent. Those angles are congruent. The other pair of angles gets bisected. So this is 5x minus 1. This one is also 5x minus 1. Or we could look at it as this one over here is 8x. So 8x and 8x, 5x minus 1 and 5x minus 1. Either way, we can add up the three angles of a triangle, whichever one we want to do. So 8x plus 5x minus 1 plus 90 is 180. So 13x plus 89 is going to give us 180. Okay. We subtract the 89 from both sides. We're going to get 13x is 91. Okay. Divide both sides by 13. We're going to get x is going to be 7. 7 times. And number 18, the last one. It's only 6. It's only 6 o'clock. I'm actually making all right time. It's not like I'm doing anything when I get home. Listen to some Dan Carlin, Hardcore History. It's a great podcast. Or Sam Harris is another great podcast. Waking Up with Sam Harris. Those are probably the two best. Waking Up with Sam Harris and Dan Carlin's Hardcore History. So we know that this is a kite. So between the two pairs of adjacent sides that are congruent angles. So we know 4x plus 13 is going to equal 5x minus 15. So we can solve for x. Subtract 4x from both sides. 13 equals x minus 15. Add 15 to both sides. 28 is going to equal x. So these are the congruent sides. These are the bisected angles. So if that's y minus 9, that's y minus 9. If that's y, this is y. So now we have 3 angles of a triangle. We can add the 3 angles of a triangle, add up to 180. So y minus 9 plus 4x plus 13 plus y is going to equal 180. So here's one angle. Here's the second angle. Here's the third angle. Well, we know x is 28. So y minus 9 plus 4 times 28 plus 13 plus y equals 180. Combine like terms. We're going to have 2y. Okay. And then we're going to have 4 times 28 is 112. So we're going to have plus 112 minus 9 plus 13 is 180. So 2y is going to equal, well, that's 125 minus 9, which is 116. So plus 116, subtract 116, 2y is going to be 64. We still see 64 divided by 2 is going to give us y equals 30. If we wanted to substitute it in to make sure we're right, we could do that. 32 minus 9 is 23. So we have 23, 23. 5 times 28. So we said 4 times 28 was 112. So 112 plus 28 is going to be 140. This one had better be 140 as well. So, minus 15 gives us 125. Minus 15. 4 times 28 we said was 112. 112 plus 13 is 125. Y is 32. So we have 64, 46. So 250. 110, 360. We're good. Okay, so that is the review. That's optional. So what is that, 45 minutes and 55 minutes? So hour and 40 minutes of video on it. Any questions, come ask me tomorrow or Thursday before the test or quiz.